Hey class, in today's lesson we're going to talk about inverse relations and functions, which is found in section 6-7, part 1 of your book. Our objective is to find the inverse of a relation or function. Our vocabulary states that if a relation pairs element A of its domain to element B of its range, the inverse relation pairs B with A. So if the ordered pair AB is a relation, then the ordered pair BA would then be its inverse. If both a relation and its inverse happen to be functions, then they are inverse functions. So if you look at the very top, there was an example from your book, and it states that you have domains of 1.2, 1.4, 1.6, 1.9, and it is a function because every function of x, or excuse me, every element of the domain matches to exactly one element of the range. So, and then when it turns back around, the inverse of R, notice that the domain and the range switch positions, okay? However, when they turn back around, the domain, we would consider the domain of the inverse, we would consider that to be unfaithful. So, yes, the original, so the relation R, is a function. However, the inverse is not also a function. All right, so in example 1, it says finding the inverse of a relation. So what is the inverse of relation S, and what are the graphs of S and its inverse? All right, so the first thing we need to do is find the inverse. So the inverse, and let me switch pen colors. So if the relation is the relation S, then the inverse of S would basically just switch your X and Y. So all the Y values are now X values, so that'd be -1, 0, 2, and 3. And all the X values are now Y values, so that'd be 0, 2, 3, and 4. Literally, they switch positions. Okay, so then that graph, if this is the original graph of the relation S, then the inverse S graph would be 1, 2, 3, 4, 5. Actually, I'm just going to graph it on the same thing so that you can see what happens. -1, 0 is here. 0, 2 is here. 2, 3 is here. And 4, 3, 3, 4 is what I'm doing. 3, 4 is here. What you'll notice is that they reflect across the y equals x line, okay? And that is what should happen when you're dealing with inverse. Let's go ahead and do the try. So it says, what are the graphs of t and its inverse? So first let's find what the inverse would be. So the inverse of t with x and y. All my y's are now x's, so that'd be -5, -4, -3, and -3. And all my x's are now y's, so that'd be 0, 1, 2, 3. So when I graph this, the original I'll graph in white, and then I'll switch to maybe like green or yellow. Okay, so the original is 0, -5, 1, 2, 3, 4, 5 down here. Then 1, -4, which is here. 2, -3. And then 3, -3. That's the original, okay? So then the new one I will put in green. The new one is -5, 0, so 1, 2, 3, 4, 5, 0 here. Next one is -4, 1, which is here. -3, 2, which is here. And then -3, 3. So again, it has been reflected through y equals x. Okay, so again, by the way, this is y equals x. All right, so let's keep going. In example 2, it says, what are the inverses of each relation? Okay, so algebraically, what it looks like to do an inverse of a function or of a relation, sorry, is that you should switch the x and y. Okay, so right now, this is my original, right? I'm going to put my original in blue. And then from here, we're going to switch positions. So x is now y is now x. So that would be x equals 4 minus 3y. And then you still solve for y. So we're going to subtract 4. So we have x minus 4 equal to negative 3y. Divide by negative 3. So y then equals x minus 4 over 3. So this one is the inverse, while the original is up here. And to check to see if they are functions, you can just check them in a graphing calculator. All right, the next one, we have y equals x squared minus 5. So again, this is the original. And then we need to switch positions. So this would be x equals y squared minus 5. Again, we're solving for y, so we're going to add 5 to both sides. We would get x plus 5 equal to y squared. And then we need to take the square root. And here you have to be very, very intentional and be sure that you write y equals plus or minus the square root of x plus 5. And you'll find out why in example 3 that you want to use plus or minus here. But that is your answer. Okay, let's do the try. So again, this is your original. Now let's switch. So that would be x equals 2y plus 8. If I subtract 8, so I get x minus 8 equals 2y. Divide by 2. So y equals x minus, well, let's do it like this. I'm going to go ahead and make this 1/2 x because I'm splitting it, okay? Minus 8 over 2, which is really y equals 1/2 x minus 4. All right, the next one, this is the original, and then we need to switch. So this is x equals y squared plus 2. We're going to subtract 2. We'll get x minus 2 equal to y squared. We need to take the square root. So then y will equal plus or minus the square root of x minus 2. And that is the second one. All right, great. Let's move on to the last example. Our last example asks, what are the graphs of the function and its inverse below? All right, so the first one should be fairly simple, and I really should have had a graph on here, but I didn't. All right, we should recognize that this is a quadratic function. All right, and as far as transformations go, -1, we should remember that it means that it's going to go down 1. So it is a parabola that has moved down 1. So the vertex is down here at 0, -1. So it's going to look something like that. That's the original. Its inverse, and I know we haven't really gotten to it, but just the square root of x plus 1, this is going to shift opposite. Remember, it's almost like being in parentheses. This is opposite. So if I see plus 1, I'm not going to go to the right one. I'm actually going to move to the left one. And what that shape looks like is, well, first of all, left one would be here. That shape, if I'm doing the positive version, would go up. And really, I should switch colors. So let me switch colors first. I'm going to say that I'm talking about left one. So it'd be here. Positive would go up, but negative would go down. So that's why we need plus or minus. Okay? And you can verify this, of course, using your graphing calculator. So, and remember, well, yeah, and that's it. Sorry. All right, let's go ahead and look at try 3. It says, what are the graphs of the function and its inverse? Okay, first of all, this is the original. Y equals 2x plus 8. That's nothing but a linear equation. So let's graph that one. All right, we would start at positive 8. So 1, 2, 3, 4, 5, 6, 7, 8. And we go up 2 to the right 1. Well, I'm out of space. I'm going to go down 2 and left 1 instead. So down 2, left 1, down 2, left 1, down 2, left 1. So right about there would be my original. Okay, the new needs to switch. So this is really x equals 2y plus 8, and we're solving for y. So subtract 8. We're left with x minus 8 equal to 2y. Divide by 2. And this is y equals 1/2 x. And remember, negative 8 divided by 2 would give you negative 4. So I'm going to now start at negative 4, because this is the new one, or the inverse. 1, 2, 3, 4 is down here, right? Slope-intercept form. This is our slope. This is our y-intercept. And we're going to go up 1 over 2. So up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2. Okay, and this graph looks like that. For the most part, I kind of missed quite a few points. All right, so that is that. We are done. Guys, if you have any questions, please be sure to come in and see me for tutoring.